In the last video, we talked about try blocks and catch blocks, and also the finally block. Now we'll look at having multiple catch blocks because we can have multiple exceptions in one single block of code. Let's look at some examples in code. So we're back where we left off, and what we're interested in here is this part of the code because that is where we're trying out our try, catch, and finally blocks. This piece of code would give us an array index out of bounds exception, and we are catching it. But there can be a lot of statements in a try block. A try block can be as big as you want it to be. You can put many other statements in try block. Before we go into multiple catch blocks, let's see what happens if we delete the catch block here completely. So let's say we do not have a catch block, and this is legal because a try block has to be either followed by a catch block or a finally block. A try block cannot be by itself. We cannot write a try block alone. We have to accompany it with either catch blocks or finally block. But the program will not give us any compilation errors if there are no catch blocks. But this code does give us some exception. So let's see what happens if we have an exception in the try block, we do not have a catch block, and we have a finally block. What happens when we run the code? Let's see. So you see something interesting happened. The first part of the code executed, the second part of the code also executed, third part of the code executed, and it got here. Here, it encountered an exception. An exception object was created, and it was thrown. However, before anything else happened, this block executed. And so we have exactly the output from this block in our output console. And then the thrown exception stopped our program. So this shows you that whether or not you have an exception, it does not matter what happens in the try block or the catch blocks. Finally block will always be executed. Here we have an exception and we have a finally block. The exception occurred, but still the finally block executed first, and then the exception stopped our program. So this is an important thing to remember. Let's bring back our catch block. Great. So now we have our catch block back, and the program will run smoothly if we execute it. Now let's introduce a couple more errors in our try block. Let's say we have an integer b. It takes the third index element of my array, which is 8. So let's say it takes 8 and divides it by 0. Now any integer divided by 0 is undefined. So this should give us some kind of an exception. Let's see what happens when we run the program. The program goes on smoothly without having this issue. Why? Because if we look at it, all of our outputs are there. We have started from the start of the program and we have reached the end of the program. So everything ran smoothly. But why didn't this give us a problem? This is because when the program came here, it entered the try block, it found an exception here, created an object, and threw it immediately. If you find an exception in the try block, after that, no matter how many other statements are there, those statements will not be executed. The very first statement where an exception is encountered will generate an exception object, and it will be thrown, and the code will exit the try block. So here in our try block, in the very first statement, an exception was encountered, and right when the exception was encountered, an object was created, and that exception object was thrown, and nothing else after that in the try block got executed. The code directly came here. When it came here, it saw that the exception object matches what we're catching. And so it printed out array index is out of bounds, and then it printed out whatever we have in the finally block, and then it went about executing the next set of instructions in our code. So the thing to remember here is that if you have a try block and you have a lot of statements in a try block, the very first statement that encounters an exception will cause the program to exit the try block and go directly to the catch blocks. Great. Now that we understand that, let's try and put this statement above this statement. Now we are dividing by 0 first. Let's run the program and see what happens. So now you see we are encountering a problem. The first statement got executed, the second and the third parts of the code also got executed. When it came to the fourth part of the code, this is where the code entered the try block. It found an exception here. It created the exception object and it threw it. It went to the catch blocks. In the catch block, we have an array index out of bounds exception. But the exception that is being generated here is different. This is not an array index out of bounds exception. What kind of exception is this? This is an arithmetic exception. And here you can see that it says that it is being divided by 0, which is why we're getting the arithmetic exception. We do not have a catch block that catches arithmetic exception. We only have a catch block that catches array index out of bounds exception. So what happened is that the program executed all of this. It came here, found an exception in the very first statement and did not even execute this statement. From this statement, it found an exception and went directly to the first catch block. Saw that there is no catch block that handles the arithmetic exception type. It went to the finally block because finally block is always executed. It printed out the finally block code output, and then because the exception was not handled, the program stopped. So how can we handle this scenario? What we have to do is that we have to include another catch block. And in this new catch block, we will be catching the arithmetic exception. And so we say that this block is catching arithmetic exception, and we give our arithmetic exception object, if it occurs, the name E. We can do, again, whatever we want with E inside this catch block and handle that exception. But for now, to keep things simple, we'll just print something out. So now we have a catch block that catches the arithmetic exception and ensures that our program will flow normally without abnormal exits. This is an abnormal exit, and all we want to do is have a program that does not do any kind of abnormal exits. Now we have a catch block that catches the arithmetic exception. Let's run the program and see what the output is. You see, our program is now running normally. The first, second, and the third parts of the code are executed, and then when the program comes here, it finds an exception, creates an exception object, and throws that exception. It comes to the first catch block. It sees that this is not the type of exception that was thrown. Great. It then comes to the next catch block. It sees that the exception object that was thrown matches the exception object that is being caught in this catch block. So it enters this, prints arithmetic exception encountered, because that's what we're printing in this block, then prints whatever we have in the finally block here, and then goes on to execute the next part of our code and reaches the end of the program, and our program ran successfully without any abnormal exits. What would happen if we take this statement and put it after our other statement? What is happening now is that this was above this statement here, right? And so the exception that was caught was the arithmetic exception, and that is what you can see here. But what if this is after this statement? What would happen if we run the code now? Let's run the code. Now you can see that we are getting array index is out of bounds output, which means that when the program came here, it found an exception, created an exception object, and threw that exception. The program exited the try block and did not execute anything after this line. Why? Because, again, as we explained before, whenever we encounter an exception in the try block exits right at that point and does not execute anything after that point in the try block. Great. So it encountered the exception here, created the exception object, and threw it. It came here and saw that this is indeed an array index out of bounds exception, and this block is catching that exception. That is why it enters this block, prints array index is out of bounds, and then goes directly to the finally block, prints whatever we have in the finally block, and then goes about executing the rest of the code. And so we can write as many catch blocks as we need. We can have many catch blocks that can catch any type of exception that you want to catch from this try block. However, this is a lot to write. If you have to write a block of code for each type of exception, that is a lot of code to write. So Java allows us to write all of this together in one catch block by using this operator. This is the OR operator, and what we can do is that we can just take arithmetic exception and put that here. And what this catch block is doing is it's catching array index out of bounds exception or an arithmetic exception. In that case, this would give us an error because arithmetic exception is already being handled here. So if an exception is handled already and then you have another catch block that is catching the same exception again, then that will give us an error. And this will be something that will stop your program from even compiling. So this would not compile. What we do is that we remove this part, and let's say we add something like or arithmetic exception. So now let's run the code again. And now you see what happens is the code comes here, finds an exception, creates an exception object, throws it. It comes to the catch block directly after this line because nothing after the exception gets executed in the try block. It comes to the catch block and it sees that it is catching multiple exceptions. It figures out which exception is thrown and matches it with any one of them, and then knows that, okay, that exception is being caught in this catch block. It prints out whatever is there in the catch block. Array index is out of bounds, arithmetic exception, goes to the finally block, prints that out, and then goes about executing the rest of the code. And so in this case also, we do not have an abnormal exit. Our program is running running normally. What you can also have is a catch block hierarchy. So array index out of bounds exception and arithmetic exception are runtime exceptions, right? And if we are to catch any other type of exception that might occur here, then what we can do is we can create another catch block and we can specify that we will be catching the parent level exception. What does this mean? Exception is the parent class of all checked exceptions as well as runtime exceptions. What does this look like? Let's look at an image of the exception class hierarchy. We know that the hierarchy starts with the throwable class, and the throwable class is at the very top. The throwable class is extended by exception class and error class. So error and exceptions are subclasses of throwable. They inherit from throwable. Underneath exception, we have many subclasses of exception. We have class not supported exception, SQL exception, IO exception, runtime exception. We have a lot of exceptions. And these are all checked exception. Runtime exception and error are unchecked exception. So we discussed this in the previous video, but keep that in mind because it is very important. So under the exception class, we have around 83 different exception subclasses, including the runtime exception. So including runtime exception, all these exceptions, we have at least 80 more subclasses, and all of them are exceptions. Everything that falls here is checked exception. The only unchecked exception under exception class is the runtime exception subclass. So this is our unchecked exception. Everything here is checked at compile time. Everything here and here is checked at runtime. Now, underneath runtime exception, we have many different exceptions. Again, you can have arithmetic exception, null pointer exception, VM out of memory exception. We have index out of bounds exception. Now, underneath index out of bounds exception, we have array index out of bounds exception subclass and string index out of bounds subclass. And this is the exception that we saw a little earlier. We also saw this exception. Again, we can have many runtime exceptions. In fact, we have around 79 total runtime exception subclasses. And these are just a few examples. We also have a lot of different types of errors. We can have virtual machine error, thread death, linkage error, and many other types of errors. There are around 12 total error subclasses, and all of these correspond to Java 11 because that's what we are using for most of these videos. And just to reiterate, this part is checked exceptions. All 83 of these together are checked exceptions except runtime. Everything under runtime and runtime itself is considered to be unchecked exception. Errors are also unchecked exceptions. So this is the only part that is checked exceptions. What I want to point out in this image is that arithmetic exception is a subclass of runtime exception. Runtime exception is a subclass of exception. Now let's say in your code you have caught arithmetic exception. In your code you have caught index out of bounds exception, which we did right now in the code. But there can be many other types of exceptions, right? And so just to generalize things, what you can do is use this class directly and say, I will be catching any exception that falls under this class. So this is the topmost class when we're talking about runtime exceptions, which means this is the most general class, and this is the least specific class when we're talking about runtime exceptions. If you want to be more specific about an exception, you use that exception directly. For example, if we're trying to catch an exception and we just use the exception class, then when we get the exception, when we catch the exception, we do not necessarily know what type of exception we caught. But when you catch an arithmetic exception or when you catch an index out of bounds exception, you know exactly what kind of exception you caught. So these are more specific. The higher you go, the less specific you become. When we're creating multiple catch blocks, what we want to do is that we want to declare the most specific catch block first and the less specific catch blocks later. And this is exactly the example that we saw in the code right now. Exception is the least specific because it is very general and it includes everything under here and here. So if we catch exception, then we are being very general. We're not being very specific. But if we catch arithmetic exception, we are being very specific about what type of exception we're catching. We want to declare the most specific exceptions first if we are using multiple catch blocks. blocks. So let's look at the code again. And here you see the more specific catch block is first. The less specific catch block comes after. And when we run this program, what happens? Our program runs smoothly and the output is fine. This part of the code is executed. The code comes to the try block, enters the try block, comes here, finds an exception. This exception is an array index out of bounds exception, and it creates that exception object. It throws that exception, and it is being caught here. Because it's already been caught here, the program comes here, it enters here, prints array index is out of bounds or arithmetic exception in our output. And because that's the only exception it caught and it did not execute anything after it, it goes directly from here to the finally block. It prints out whatever we have in the finally block here, and then goes about executing the rest of the code. To understand this properly, let's introduce a new error in our try block. Let's say we have a string. The name of the string is test, and what we're doing is that we're trying to initialize it, but not with a value. Let's just initialize it as null. We're trying to print test, which has a null value, and test is a string. And we will not make this the first statement right now. Let's just see what happens here. We run the program, and what happened here is that after executing these parts, the program got into the try block. It came here, found an exception. This exception is an array index out of bounds exception. And so after this, it does not execute any of this. It directly goes to the catch blocks, finds the exception here, prints this out, and the program runs normally after that. So because we encountered an exception here already, nothing else got executed. And so our program was able to handle it gracefully. But what if this is at the top? Let's see what happens now. What we tried to do is that we tried to print the length of our test variable. However, the length of the test variable is undefined because test has null value. What happened here is that the code executed this part, came to the try block, got in here, found that the string test has null value, and then it tried to print out the length. When it tried to print out the length, it encountered an exception. It created that exception object and it threw that exception. We don't know what that exception type is. When it came here, it found that exception, created that object and threw it, and did not execute anything after it. It came to the catch block. It found that that exception is not the exception that is being caught in this catch block, so it does not enter the catch block. It then comes to the second catch block and finds that it is catching exception, which is the very top level and the most general type of exception. Catching this will catch everything here. Anything that happens out of the 79 total runtime exception subclasses, it will catch because this is the top level class for exceptions. So no matter what happened here, this will be caught in this block. It enters this block, prints out parent level exception caught, then goes to the finally block, prints out finally block output, and then goes about executing the rest of the code. What if we did not have the second catch block here? What if we delete this? We'll find out exactly what kind of exception we are dealing with. So let's run the program. And you see this time the program stopped abnormally. And we have a null pointer exception. This has happened because we have a null value whose length we're trying to print. So we can either add a new catch block that catches null pointer exception, or we can add it here with an OR operator. It's really up to us what we want to do with this. And I hope you know by now how you would want to handle that exception. Let's bring our parent level exception catching block back. So here we can see that the hierarchy is maintained. The most specific ones are caught first, then the lesser specific ones are being caught. Exactly as we discussed here. We declare the most specific ones first, and then we catch the least specific exceptions. What would happen if we catch the less specific exceptions first? So let's remove this from here and put it on top. You see, we immediately get an error. Why? Because it says that this type of exception has already been caught. Where has it been caught? This parent level exception here is catching all types of exceptions that we have tried to catch after it. When we are declaring this here, this will catch array index out of bounds exception. This will also catch arithmetic exception. So declaring these two more specific exceptions after we have already caught them will give us an error. So the less specific ones should always be after the more specific exceptions in our catch blocks. And in this way, we won't have any errors. Hopefully you have understood how we can use multiple catch blocks, and I'm hoping that you also have a good understanding of the exception class hierarchy. And I hope it is clear by now that the finally block always gets executed, regardless of whether the exception is caught or not caught, and regardless of what happens in the catch or the try blocks.